I saw the hairline crack beside the locator pin and felt it open under my thumb. My superiors wanted the line moving, and the quota board still read 18 frames. I tied the wire tag myself, removed from service, dated June 1943, and shut off my air valve. The rejected plate sat on the quarantine rack with fresh stamp marks. After that, every hammer sound felt like a question, with no safe answer. June 1943. A rear area repair and production shop sits beyond a rail spur and a birch line. The place is not at the front. It is part of the machinery that keeps the front supplied. That summer, the operational situation is defined by air defence readiness. Rail junctions, depots and river crossings are targets. A single raid can burn fuel stores, smash cranes and block a line for days. Anti-aircraft mounts are not glamorous items. They are brackets, cradles and rotating rings, yet without them a gun is only a heavy tube on the floor. The shop's task is narrow and measurable. Produce and repair mounts that accept British-supplied components. Some parts arrive already finished. Other parts arrive as assemblies that must be fitted to local mount frames. Compatibility depends on holes, pins, and surfaces aligning on the first attempt. Inside the shop, the main noise comes from riveting. Pneumatic hammers rattle against steel. Hot rivets move in buckets. A riveter's hands learn to feel the moment a head seats cleanly. If a rivet sets crooked, the plate can walk under recoil. If a plate walks, the mount can loosen. If the mount loosens, a gun can throw its aim off a moving target. The anchor of this story is a single routine procedure, a hole spacing check on a gun mount line. It depends on one gauge template made of thick steel. The template has 2 locator pins and a row of hardened bushings. It is used every shift. It is supposed to be trusted without argument. The riveter is a Soviet worker assigned to that line. Her name appears in a surviving shift roster as Yelena Sokolova. The roster lists her role, not her rank, because she has none. Her duty is to rivet side plates onto a mount frame after the drilling station. Her measurable constraint is posted on a board near the tool cage. 18 frames per shift if the drills keep pace. No delay longer than 15 minutes without a foreman's signature. There is another figure in the shop, less visible and less accepted. A British technical inspector attached to a liaison mission. And his name appears on an inspection note as Thomas R. Bennett. He is not an officer giving orders. He is a specialist sent to confirm dimensions and drawing revisions. His measurable constraint is time. His travel paper allows him only 2 days in this district. A train schedule and a courier bag dictate his next move. Bennett carries a folder with drawings and revision notices. Some are copies with stamps and translated annotations. Some are faded from handling. A drawing revision is not a dramatic thing. It is a letter, a date, and a few lines of change. In wartime production, that letter can decide whether parts mate or fight. The shop has pressure from above. Quota pressure arrives as numbers, not speeches. The front does not wait for perfect paperwork. The foreman's job is to make metal turn into finished pieces. The quality controller's job is to keep failures from leaving the building. Those jobs collide more often than anyone admits. On the first morning of Bennett's visit, the line seems stable. A stack of mount frames waits in a staging rack. Each frame is a welded base with 2 side plates. The side plates have drilled patterns that must match British parts. A British-supplied elevation gear housing will bolt onto those patterns. If the pattern is off, bolts will not seat. If bolts are forced, threads strip and stress concentrates. Under recoil, stress finds the weakest corner. Yelena starts her shift with the routine she repeats daily. She checks her hammer. She checks the air hose. She lays out rivets by size. She watches the drilling station feed the first frames down the rollers. The gauge template comes out at the start of the shift, and a mechanic sets it on the first drilled plate. 2 pins drop into their locating holes. If the pins drop, the foreman nods and moves on. The bushings line up with the remaining holes. A check pin is pushed through several positions. This is how the shop proves to itself that the jig is correct. That morning, the check seems to pass. The pins drop with a familiar clunk. The first frames move forward. Riveting begins. The first sign of trouble is small. It is not a broken machine. It is a fit check failure at the inspection bench. A British component is brought from a crate for a trial fit. The housing edges touch the plate, but the bolt holes do not center. One bolt starts, another catches at an angle. A third will not enter at all. The Soviet quality controller marks the frame with chalk. A stamp is pressed onto a tag tied with wire. That rejected, for mismatch at interface holes. The frame is set aside on a rack labelled quarantine. The foreman does not panic. One rejection can be blamed on burrs. He orders a ream and a second try. A worker reams a hole. Metal curls fall to the floor. The housing is tried again. The bolt still fights. The quality controller records it in a log. The entry is short. Time, bench number, rejection reason. No commentary, no blame is written in the book. Then a second frame fails, then a third. The failures do not look identical. One hole is tight on the left, another is tight on the right. The pattern is not wildly wrong, it is shifted just enough to ruin interchangeability. This is where quota pressure starts to show teeth. A line can tolerate a few repairs, it cannot tolerate uncertainty. If the jig is wrong, every frame is suspect. And if every frame is suspect, output collapses. The foreman walks down the line with a clipboard. He points to the growing quarantine rack. He asks the drilling operator how the template check went. The operator says the pins dropped and the check pins went through. The foreman turns to the quality controller. He asks if the British housing might be the problem. He wants the problem to be somewhere else. Bennett is called over. He looks at the rejected frame and the housing. He does not speak first about blame. He speaks about revision. He asks which drawing number the shop is using. A translator repeats the question. The foreman answers with confidence. He gives a drawing number from a board near the drill station. Bennett opens his folder. He finds the drawing number, then he finds a thin revision slip clipped behind it. The slip carries a letter and a date. It notes a change to a hole spacing reference point. A small change made after field reports. A change meant to reduce stress on one bracket. A change that would be invisible unless a shop updated its jig. Bennett asks whether the shop received the revision notice. The foreman says the shop received many papers. Some arrive late, some are copied, some are translated twice, some are posted then replaced by newer ones. In the war, paper can lag behind metal. That afternoon, the foreman orders another template check. The gauge template is brought back to the drilling station. The same two locator pins are dropped into the plate. They drop again. The check pin slides through the first bushing. It slides through the second. On the third, it catches. A worker twists it. It goes through with a scrape. The foreman calls it acceptable. He wants productioner to keep moving. He points at the quota board. 18 frames is still the number. He does not erase it. He does not lower it. Yelena hears the argument from her station. She is not part of it. Her hands keep working while she listens. The line depends on each station trusting the previous one. When trust breaks, time bleeds away. Yelena is not a designer. She is not an engineer with a diploma, but she has handled enough misfit parts to recognize a pattern. If bolt holes fight in the same direction across multiple frames, it is not random. It is a reference problem. It is a gauge problem. It is the kind of problem that survives hasty checks. In the second shift, she sees something the others miss. A worker sets the gauge template down hard on the bench. The steel rings on steel. The template slides. Yelena catches a flash along one edge, a line that does not look like a scratch. She asks to see it. The worker shrugs and hands it over. Yelena runs her thumb along the edge, careful of burrs. She finds a hairline crack thin as a thread. It runs from a corner toward one of the locator pin mounts, not through the pinhole itself, but close enough to matter. A crack in a template is not just damage, it is movement. Under load, a cracked plate can flex. Under repeated use, flex becomes a permanent shift. Yelena holds the template at an angle to the window light. The crack becomes clearer. It has grime in it. That means it is not new. It has been there through several shifts. She brings it to the quality controller. The controller looks, then looks again. He checks the template against a flat edge. And he does not see a dramatic bend, he sees the possibility of one. In production, possibility can be enough to stop a line, but stopping a line carries punishment if the reason is not accepted. The foreman is called. He arrives annoyed. He looks at the crack. He says it is small. He says the pins still drop. He says the check pin still goes through. He says the war does not wait for perfect tools. Yelena speaks carefully. She does not lecture. She points to the rack of rejected frames. She points to the housing that will not seat. She says the crack is close to the locator pin. She says the template might be shifting the reference by a small amount. A small amount is all it takes. The foreman says the drilling jig is the real reference. He says the template only confirms. He says they can keep drilling while a new template is requested. Well, Yelena does not accept that. Not because she wants a fight, because she has seen what happens when a bad reference continues. The bad reference multiplies defects faster than any rework can recover. If they drill 100 wrong plates, the shop will be buried. Bennett is brought in again. He looks at the crack. He asks, through translation, when the template was last calibrated. The mechanic checks a tag on the template handle. The tag is worn. The date is months old. It was stamped when the template was first issued. No later mark is visible. Bennett asks for the drawing board again. He asks for the shop's current drawing copy. He lays his revision slip beside it. The two documents match in number, but not in revision letter. The foreman tries to contain the damage. He says they can adjust the drill stop slightly, and he suggests they can open the holes with a riveter fit. The quality controller shakes his head. He has seen bolt holes enlarged until bolts sit loose. Loose bolts under a coil are a slow failure. Slow failures kill quietly. Yelena makes her decision. She stops her station first. She sets down her hammer. She pulls the air valve. The hiss dies. Then she steps to the line feed and signals a halt. It is not a dramatic gesture. It is a practical one. No point riveting plates onto frames that may be wrong. The foreman's face tightens. He says stopping the line will be written up. He says output will fall. He says the depot is waiting. He does not raise his voice much. He does not need to. The weight of procedure sits behind him. Yelena asks for a measurement, not a feel, not a quick pin drop, and a measurement against the latest drawing revision. If the latest revision is correct, the jig must match it. If the jig matches, the template must be sound. If the template is cracked, it must be replaced before further checks. The quality controller supports the request. He points to the inspection log entries. He notes the repeated mismatch. He says the rejection rate is already recorded. If they continue, the record will show negligence. That word is not spoken, but it is understood. Bennett offers a practical method. He asks for a clean plate, not yet riveted. He asks for a set of calibrated pins and a steel rule. He asks for the drawing revision slip to be treated as current until confirmed otherwise. A bench is cleared. Tools appear. A translator stands close. The mechanic brings gauge blocks and a worn micrometer. The micrometer is checked against a standard because truss must be rebuilt. It reads close enough for shop work. They lay the drawing copy on the bench. Bennett points to the hole pattern. He indicates the datum line. The translator explains the datum to the foreman. The foreman listens, arms folded. They measure the hole spacing on a rejected plate. They measure the spacing on a freshly drilled plate. They compare both to the drawing. The differences are not enormous. They are consistent in direction. The pattern is shifted slightly from the datum. Then Bennett points to the revision slip. It shows that the datum reference was moved in the updated version. If the shop is still using the older reference, its jig will produce a pattern that looks correct to itself. It will also fail against newer components. Hesisimal is how war production breaks, not with missing effort, but with mismatched papers. The foreman argues that the shop's component stock is older. He says the parts they have should match older holes. Bennett asks to see the component crate markings. The markings show recent shipment dates. The components are newer. The front receives what arrives, not what a shop prefers. The shop must adapt. They turn back to the cracked template. They place it against the measured plate. The locator pins drop, but the crack shows a slight separation near one mount. When pressure is applied, the crack closes. When pressure is released, it opens. That means the pin position can shift by a small amount. It also means the template cannot be trusted for repeated checks. It can pass in one moment and fail in another. The line is now halted. The silence spreads unevenly. Some stations keep cleaning. Some workers keep their hands busy to avoid being seen as idle. The foreman walks to the office window and looks out. He calculates lost frames. He calculates his report to the depot. Yelena stays by the bench. Her action has made her visible. Visibility can be dangerous in a system built on compliance. Yet there is also protection in evidence. Evidence is what she asked for. Evidence is what the log already holds. Decision is made to reset the drilling jig, not to guess, to align it to the latest drawing revision. The drilling operator loosens the jig bolts. The jig is heavy. It sits on a fixture that has been in place for months. Loosening it is like admitting the past week might be wrong. That admission is hard, but the pile of rejected frames makes it unavoidable. Here, the mechanic brings alignment pins. The quality controller brings a clean inspection sheet. Bennett places his revision slip on top of the drawing and writes the letter large. The translator repeats it twice so it stays in memory. They set the datum. They adjust the jig stops. They lock the jig bolts. They drill a test plate. They deburr it. They bring the British housing again. The fit check is slow and deliberate. A bolt is inserted. It turns by hand without cross-threading. A second bolt follows. A third slides in cleanly. The housing seats flush. No gap appears under the edge. No one cheers. The result is relief, not celebration. The foreman asks if it will hold under recoil. Bennett does not make speeches. He points to the drawing's stress notes and the revised bracket change. Yet he says the revision exists because earlier patterns showed weakness. He says forcing bolts defeats the purpose of the revision. The quality controller stamps the test plate as accepted. He signs the inspection sheet. Bennett adds his own signature as witness. The translator writes the drawing number and revision letter in clear script. Now comes the hardest part. What to do with the frames already drilled. The quarantine rack holds several. Some can be reworked. Some will become scrap. Scrap is not only metal wasted, scrap is time, energy and transport capacity lost. It also reveals failure. Failure is not a word the system enjoys. The foreman wants minimal scrap. He suggests elongating holes. He suggests selective fitting. He suggests marking certain components for certain frames. That approach destroys interchangeability. That interchangeability is the quiet miracle of mass war production. Without it, every mount becomes a custom job. Custom jobs consume months the front does not have. The quality controller refuses selective fitting unless authorized. He says the inspection note must be clear. If a mount fails later, the paperwork will be traced. The trace will lead back to this room. Yelena, still not an engineer, suggests something practical. Ream only within limits, using the drawing's tolerance notes. If the mismatch exceeds that, reject the plate. She says to recheck each reworked plate with the corrected jig reference, not the cracked template. Her voice is steady. She does not demand praise. She demands method. They agree on a controlled rework. Frames with minor mismatch are re-drilled using guided bushings, and frames with major mismatch are stamped rejected and set aside for scrapping or remelt. Each reworked plate is checked with a new temporary gauge made for the corrected pattern. The mechanic cuts a temporary gauge from thicker stock. He drills it using the corrected jig. He hardens the bushings as best he can in wartime conditions. It is not elegant. It is functional. Most importantly, it is not cracked. The crack template is tagged. A wire tag is tied through its handle. The tag carries the date and a short reason. Cracked near locator pin mount. Removed from service. Requested replacement. The tag is initialed by the quality controller. That tag becomes a proof detail. It is the shop admitting, in ink, that a trusted tool became unsafe. A rejected frame is pulled for documentation. It carries stamp marks on its attached card. One stamp indicates shop inspection, another indicates rejection. The stamps do not tell a story by themselves. They tell only that the system noticed. Bennett writes an inspection note. It is not a long report. It is a brief statement with a drawing number and revision letter. It cites the mismatch discovered under fit checks. It records that the jig was reset to match the latest revision. It records that the cracked template was removed from service. It does not claim a miracle recovery. It does not claim heroic output. It claims only what was observed and signed. The note is signed by Bennett. It is countersigned by the Soviet quality controller. The foreman adds his signature with reluctance. He knows signatures can be used later. He also knows refusing to sign looks worse. A copy is made for the depot office. And another copy stays in the shop log. The paper is filed, not displayed. No banner is hung, no meeting is held to praise caution. Wartime factories rarely reward disruption, even when disruption prevents disaster. The line restarts the next morning. The air hoses hiss again. The drilling station moves with a different rhythm. More checks are done. The workers complain quietly. Extra checks mean extra minutes. Extra minutes mean fewer frames. But fewer frames that fit are better than many that fail. Yelena returns to her station. She rivets plates again, but now she watches the fit check bench more closely. When a frame passes, it moves forward. When one fails, it is not hidden. It is marked and recorded. That is a small cultural shift. It is not a revolution. It is a survival adjustment. quota pressure does not vanish. The third board still shows a number, the foreman still watches the clock, but he also watches the quarantine rack. He has learned that hidden defects are worse than visible delays. Visible delays can be explained. Hidden defects can arrive at the front as broken metal. These stakes are not abstract, a gun mount carries recoil forces. If a plate is misaligned, recoil loads do not spread evenly. One rivet line takes more than it should. A crack can start at a drilled edge. A crack grows with every burst. When a mount fails, the gun can jam or shift. A jam at the wrong moment can mean a bomb hits a rail yard. A shifted aim can mean a fighter crosses unchallenged. These are not cinematic outcomes, they are procedural failures with lethal timing. In later shop records, the impact is noted only where the paperwork allows. One log entry shows hours lost to jig reset. Another shows a count of rejected frames. A third shows the restart time. The records do not say the front was saved. They do not say the war turned. They show a local correction that prevented a batch of defective mounts from leaving the building. Bennett leaves on schedule. He takes his folder and his notes. He does not carry away the shop's gratitude. Foreign inspectors are rarely loved. He carries away a signed document that proves a revision was enforced. That document matters to his superiors. It also matters to the Soviet shop because it shares responsibility. Before he leaves, he walks the line once more. He does not lecture. He points to the drawing board and asks that revision letters be posted more clearly. He asks for a simple practice. When a revision arrives, yes, the older copy must be marked obsolete. It is a small administrative step. In wartime, small administrative steps prevent large mechanical failures. The foreman nods. He does not promise perfection. He promises compliance because compliance is safer to promise. Yet the drawing board is changed. A corner is marked for revisions. A pencil note appears. Check revision letter before jig adjustment. No signature, no flourish. Yelena does not receive a medal. Her name does not appear in a newspaper. Her action exists in the margins, in the shift roster, in the inspection note, in the tag tied to the crack template. The system remembers her only as a worker who stopped output. Whether that is seen as courage or inconvenience depends on who reads the paper. Weeks later, a replacement template arrives. It is heavier and cleaner, and it carries a calibration stamp. The mechanic hangs the old cracked one on a nail as a reminder. Not a public reminder. A private one. Tools fail. References drift. Paper revisions arrive. If workers pretend none of that happens, the front pays the price. The story ends where it began. In a rear area shop far from the front line. A place where history is made through routine checks and quiet refusals. A riveter choosing evidence over speed. Technical inspector insisting a revision letter matters. A crack gauge template removed before it multiplies failure. If more overlooked workshop stories like this matter to you, follow the channel and stay with the small details that kept war machines working.